Yeah, hello, good evening, everyone. Only one person is here, I think. Okay. Yeah, good evening. So we should wait for 5 minutes more. So have you watched the lecture regarding this week 9 lectures? It's fine if yes or no. Okay. Okay, I think nobody will come, so let's start. So today this is week 9 assignment for the physics of renewable energy course. No one is here today. It's fine. I'll record it. So in this lecture, or we will complete the assignment questions regarding week 9. So I am Ravi from IIT Bombay, a PMRF research scholar here. So let's start with the first question, which says a fuel cell needs continuous replacement of which of the following? So you just need to tell me which among these need to be separated or need to be replaced with time. Is it fuel, oxidizer, separator, or both fuel and oxidizer? Okay, so this is a fuel cell. Here we can see some fuel is coming here and oxidizer is coming from this side. So what happens? This oxidizer and this fuel reacts and they generate electrons, and these electrons flow from the outer circuit and which generates electric current. So this one is the first question. I am repeating once again. A fuel cell needs continuous replacement of which of the following? So options are fuel, oxidizer, separator, or both fuel and oxidizer. See, this is a fuel cell. And what happens in a fuel cell? A fuel reacts with oxidizer and generates electron, which flows from outer circuit and results in electric current. So what is coming here? Fuel, and going out fuel. It is also oxidizer coming here and going out. So from this picture it is clear, like fuel and oxidizer are the two things which need to replace time to time or continuous replacement. So these two are in the option D. So correct answer will be option D for this. Let's move to the next question, which says at the cathode of hydrogen oxygen alkaline electrolyte fuel cell, the reaction occurring is. So you just need to tell me the reaction at the cathode of alkaline electrolyte based fuel cell. So these are the options A, B, C or D. No one knows. C. Just think once again. This is an alkaline electrolyte, so generation of OH should be here. In the C, OH is being consumed. Now would you like to change your answer? A. Yes. Here this is the fuel cell, alkaline based fuel cell, and here we can see this is the reaction at cathode which generates OH negative ions which flows through this electrolyte. So yes, answer for this is A. Let's move to the next question, which says among the following, which are the techniques that can be used to increase the slow reaction rate? You need to tell me the techniques which are used to increase the slow reaction rates in a fuel cell. These are the options: the use of catalyst, rising in the temperature, increasing in the electrode area, or reducing the cell temperature. Which one is correct? No idea? Okay, these are the two things which you need to think. With the temperature, the reactions rate increases or decreases? Or in other way, we can say that efficiency of fuel cell increases with temperature or decreases? It increases. So reducing the cell temperature is not correct. But yes, why we use catalyst? To increase the reaction rate. So one is correct. Second, rising in temperature, correct. Third, increasing the electrode area, correct. Because more the surface area, more the reaction rate will occur, or more the means different reactant will have more space or more surface to cover. So yes, A, B and C. Here also we can say use of catalyst, rise in temperature and increasing the electrode area. So option A, B, C are the correct answer here. Let's move to the next question, which says the operating temperature ranges for alkaline fuel cell. Do you have any idea in what range an alkaline fuel cell works? In what range an alkaline fuel cell works? Any idea? No, it's fine. This is the chart given in the lecture. Here we can see this is the alkaline fuel cell, and in the alkaline mobile ion is OH negative, and the temperature range is 500 to 200 degrees Celsius. So answer here will be C. Yes, C is the correct answer here. Let's move to the next question, which says hydrogen has a higher energy density of. You just need to tell me the value of hydrogen energy density. Hydrogen energy density. D. Yes, Kokila, correct. 140 megajoule per kg. Option D is the correct answer. Great. Let's move to the next question, which says choose the correct options with respect to hydrogen. So this question is just about the properties of hydrogen. So these are the options. Is hydrogen flammable or not? Storage is difficult or not? Storage and transportation cost is high. So Kokila saying option D is the correct answer. But no, D is not the correct answer. Hydrogen is flammable. It is not correct. Hydrogen is flammable. The gas is flammable. It is storage difficult. Transport is risky. So option 1 is wrong. B right, C right, D is wrong. Yes, Kokila, now you are correct. B and C are the correct answer. So from the next time, read question carefully and read options as well. So this is the next question, which says in an acidic fuel cell, choose the correct options. This question is about acidic fuel cell. First, let me know the ions in acidic fuel cell. OH negative or H positive? Which one will be the ion in acidic fuel cell? OH negative. Yeah, hydrogen will be there, right? Sorry, these are the options. Hydrogen ion should pass through the external circuit, or hydrogen should pass through the electrolyte, or similarly for electron should pass through the external circuit, or electron should pass through the electrolyte, not ion. So among hydrogen and electron, which one flows through the external circuit and which one flows through the electrolyte? That's just the question is saying. Which ion is flowing from where? B and C. Hydrogen flowing through electrolyte, and yes, great. Here you can see this is the fuel cell, and this ion is flowing through the electrolyte, and these electrons are flowing externally. So yes, B and C are the correct answer here. Let's move to the next question, which says what are the inputs for fuel cell or of a fuel cell? These are the options. Very simple question. What are the inputs of a fuel cell? A and B. Yes, hydrogen and oxygen. This is the fuel cell, and hydrogen and oxygen are the inputs. Great. Yes, A and B are the correct answer. Let's move to the next question, which says what are the outputs of fuel cell? And these are the options. From the fuel cell, what we get? Electrical energy, heat energy, light energy, or water. Kokila saying water only. So are we using fuel cell only for water? So now you are saying only one, or A or D both? Okay, A is right. Kokila saying water as well. And what about B or C? Byproduct is water, right? So if I am saying O2 plus H2O, 2H, sorry, 4H. So this reaction is endothermic or exothermic? Will there be some kind of heat? Yes, it will be. Here, along with this water, there will be some heat as well. So option B is also correct. But light energy, no. No light. Here you can see this is a fuel cell, and electrical energy, heat energy, or water are the outputs from this fuel cell. So option A, B, and D are the correct answer here. Okay, now let's move to the next question, which says what are the advantages of fuel cell? So these are the options. What are the advantages of fuel cell? Zero emission, long cycle life, no noise pollution, and cheapest source of energy. What are the advantages of fuel cell? Okay. T Kamaksi is saying D. What about Kokila? A and B. Okay. And C as well. And D as well. Yes or no? Not D, right? Not D, right? Or D is here? Okay, zero emission, we can see only what is the byproduct. So A is correct. Long cycle life, yes, because cycle life of electron or like this lithium ion battery drops because ions got stuck inside these electrodes, but nothing is happening here. No noise pollution, yes, there is no noise pollution. It's very silent source of energy. Cheapest source of energy, no, this source is not cheapest. It seems to be cheapest, but hydrogen storage and transportation is very difficult. That's why this is not the cheapest source of energy. Here you can see zero emission, yes, long life, yes, noise pollution, yes, and disadvantage is what? Expensive source, because cost of implementation is high. And in implementation, what we have? Storage of fuel, capturing hydrogen, and transporting this hydrogen. So correct answer will be A, B, and C. A, B, and C. Okay, so let's move to the next question, which says choose the losses responsible for voltage drop in fuel cell. There are some losses which are responsible for voltage drop in fuel cell. You just need to tell me the name of those. These are the options: ohmic loss, activation loss, concentration loss, or all of the above. Type of losses are here. You just need to tell me which are associated with fuel cell. Are ohmic losses there? Are activation losses there? Are concentration losses there? A, okay, means ohmic losses are there. Okay, ohmic losses are present everywhere. What about others? Other kind of losses? C, concentration losses be there. Okay, A and B. Kokila saying ohmic losses and activation losses, and Kamakshi saying activation losses and concentration losses. So why don't you combine and say all these three? Yes or no? Yes, all three are associated with this fuel cell for the voltage drop. These are the, this is an snap from lecture only. So activation losses, ohmic losses, and concentration losses, all three are there. So correct answer is D, all of the above. So let's move to the next question, which says choose the correct option or options regarding functioning of microbial fuel cell. First, let me know, do you know what is this microbial fuel cell? Yes, no? Have you heard about this? Do you have any idea regarding this MFC? MFC is the short form for this microbial fuel cell. Yes or no? I'm just expecting an answer, yes or no. It's fine if you know. It is even fine if you don't know. No. Okay. So see, these microbial fuel cell are a kind of fuel cell only. What happens? There are some organic waste which is consumed by this microorganism. How should I draw? Okay, let it be. So these are the microorganisms. They, what they do, they just decompose this organic thing, or in case of a microbial fuel cell, what they do, this is a fuel and these are the microbes there. What they will do, in the presence of oxygen, they will generate ions or electrons or energy or electricity from the fuel by decomposing that. So you can understand here the reaction is happening with the help of microorganisms. Just this is the difference between a normal fuel cell and microbial fuel cell. But for the waste management, this fuel cell is very efficient or very new field. Okay, so these are the options for you. What? Choose the correct option regarding functioning of microbial fuel cell. What they do they convert light energy into electrical energy? Catalytic reaction is done by microorganism, involves bacterial interaction in the cell, or all of the above? B and C. Why not A? Why not A? Which word is there which is preventing you to choose option A as well? Just write the word which is incorrect or which seems to be incorrect to you. Yes, Kopila, you are right. It should be chemical energy into electrical energy, but it is saying light energy into electrical energy. So I think Kopila is watching videos or lecture videos regularly. That's great. Keep it up. So option A is wrong. B and C is correct. So answer here will be, so here we can see convert chemical energy into electrical energy. Chemical energy, not light energy. Catalytic reaction by microorganism, yes. Involves bacterial interaction, yes. So all of the above, no, because option A is incorrect. So answer will be B and C. Okay, so we are done for today. I'm going to upload this video on YouTube and will meet you in next lecture. That might not be in the next lecture, might not be in the next Friday because I won't be available. So we'll see when I can take the lecture, or even if it is on Friday, you will get an email. Thank you. If you have any question, you can ask here or there, or even you can write an email to me. I'm writing my email ID here, ravikr@iitb.ac.in. So in case you have any question, you can write an email, or you can ask questions in comment box in the YouTube video or below the YouTube video. I'll be happy to I will be happy to answer your queries. Yeah, good evening, Dr. Narveer Singh. You are very late today. Actually, we are done with the lecture, but I am going to upload this lecture on YouTube right now. And if you have any doubt or anything you want to clarify, you can write an email to me, or you can ask question in the comment box. Okay, I am closing this meeting. I am ending this meeting today. So take care. Bye bye.